As our dental cone beam customers grow their practices with implant treatment, we have found that some doctors have valued a refresher on some of the mechanical concepts that may play a role in their implant design. In this short video, we're going to review some concepts from a paper written by Dr. Lawrence Weinberg that discusses, among other things, how cuspal inclination can affect the torque in an implant design. To begin, it's worth a reminder that torque is essentially a force multiplier. If you have ever used a crowbar, you know that relatively small forces applied at some distance from a fulcrum can result in very large forces on the other side of that fulcrum. In this video, we wanted to zero in to show how this concept comes into play with design of the cuspal inclination angle of an implant. In this case, we're going to compare a force diagram for a simplified implant model with two different cuspal inclinations. When an implant, or a tooth, makes contact with an opposing force, the resultant line of force is perpendicular to the impact area surface. So in this example, even though a force may be exerted straight down, the angle of the contact point redirects that force at an angle. Now, to determine the impact of the torque, we compare the line of this force to the center of rotation, which is essentially acting as a fulcrum. Most commonly with an implant, this center of rotation is going to be located near the crest of the ridge. The magnitude of the torque created by the force is a function of the distance to the center of rotation along a line that is perpendicular to that line of force. The torque is calculated by multiplying this force by this distance. While a natural tooth has the periodontal ligaments to distribute the lateral forces caused by torque, the osseointegration of an implant cannot do this nearly as well. As a result, this torque tends to concentrate the lateral forces created by that torque in the crest of the ridge. So, if the implant cusp incline is high, the torque it creates can result in significant lateral forces at the crest of the ridge. Now, let's look at how the force dynamics change for an implant that utilizes a smaller cuspal incline. As you can see, a lower cuspal incline can significantly change the angle of the force that travels through the implant. And because of this new angle, the distance from the center of rotation dramatically decreases. A dramatic reduction in this distance means there is also a dramatic reduction of torque. The reduction in torque means there's less lateral forces felt by the crestal bone.